All right, this is Mr. Wyrick. I'm going to be going through these notes with you real quick. These will be the ones for Friday. So yeah, congruence criteria, very similar to the 3-2-1 notes, talking about these are the things that we can use to prove these congruent. So when we have two polygons, this will apply to not just triangles, but other stuff. We're just kind of focusing on triangles now. They are congruent if and only if their corresponding parts are congruent. You can see we've got these rotated, we've got these flipped, but what happens is we have this one that's marked with a single hash mark, those match up. So this is a corresponding part. We have a corresponding part here with 2, we have a corresponding side here with 3, and then we've got 1, 2, and 3 arcs, kind of like what you were doing with the assignment from yesterday. Show that the polygons are congruent by showing all their parts are congruent. So you would write these as statements. BC is congruent to XY, AB is congruent to WX, AD is congruent to WZ, CD is congruent to YZ, angle A is congruent to angle W, angle B is congruent to angle X, angle C is congruent to angle Y, and angle D is congruent to angle Z. All of the different parts, not just the sides, not just the angles, but all the sides and all of the angles. If we look at this one in the diagram, triangle RSV is congruent to triangle TVS. Find the values of X and Y. This is 78, this is 90, meaning that this angle over here needs to be the rest of that triangle. We know they add up to 180. So 180 minus 90 is 90, and 90 minus 78 is going to be 12. So this is 12, so X is also 12 because it's the corresponding part. On this other one, we have 24 for this length. We have 2y minus 1. So this is 2y is equal to 25, so y is going to be 12 and a half. On the next one here, the third angle theorem, kind of important here. If two angles of a triangle are congruent to two angles of the second triangle, then the third angles of the triangles are congruent. This is just a math thing. All three angles have to add up to 180. So if we have two of them that are the same, mathematically, the third one can't be anything but the same. It has to work. Then we write a 2-column proof here. Given that angle J and angle P are congruent, JK is congruent to MP, JL is congruent to PL, and L bisects KM, prove. Okay, so the first thing we would write down would be all our stuff that's there that's given, and we would write reason number 1, this was given to us. The next step that we can take here, we can pick one of the two things. We still have to prove the other angles congruent, and we need this third side. So I can say that KL is congruent to ML because of the definition of a bisector. We have L bisecting KM. Bisect means it cuts it equal, half, okay? Then we can say this right here, angle JLK is congruent to angle MLP because those are vertical angles. So then I have two angles with those vertical angles, which means I can say angle M and angle K are going to be congruent because of the third angle theorem that was just on that previous slide. Okay, so then I've got all three angles, I've got all three sides. I can write this that I was supposed to prove. Triangle JLK is congruent to triangle PLM, and I can say that because all sides and all angles are congruent. Your assignment for today is there in Schoology. It's pretty similar to yesterday's. Again, this one's going to be a Google Doc. You might need to download it as a PDF and annotate it with Kami if that'll help, if that'll make it a little easier. Just take your time, try to get it right. We will go over this when I return.